Huh? Yang kelasnya Sir. Yang kelasnya Sir. अब नहीं होना वो उस वाला तो वॉइस कम करवाना बताइए एक डिलीट करना ये तो लाइव स्ट्रीम चालू है चार्जिंग कम है ना आवाज आ रही है
हेलो गुड मॉर्निंग एवरीवन आवाज आ रही है सबको ओके गुड मॉर्निंग एवरीवन आवाज आ रही है सबको ओके चलो स्टार्ट करते हैं ओके टुडे वी आर गोइंग टू टॉक अबाउट द ईस्टर्स ओके चलो ईस्टर्स के बारे में पढ़ते हैं ओके सो लेट्स स्टार्ट अबाउट द ईस्टर्स ओके Esters. What is meant by esters? Okay, these are the derivatives of carboxylic acids. Okay, we are considering that esters are the derivatives of carboxylic acids. Okay, so how they are the derivatives of carboxylic acids? Listen, carboxylic acid contains which functional group? Like similarly, C double bond O, then OH. Okay, these are the carboxylic acid group. But in the esters, the hydrogen atom of this carboxylic group, okay, is replaced by alkyl or aryl group. Okay, listen here. This hydrogen atom is replaced by alkyl or aryl group. Okay, alkyl group or aryl group. And here, if you talk about the particular aliphatic acids, you can also talk about the aromatic acids. Okay, so these are the derivatives of carboxylic acids where the hydrogen atom of carboxyl group is replaced by alkyl or aryl group. These are nothing but the esters. Okay, esters are also having a particular peculiar characteristic order, smell and taste and all these things. Okay, they are the characteristic properties, they having characteristic properties. Let's talk about the examples and nomenclatures about it. Okay, so see, as you know, first carboxylic acid, only one carbon carboxylic acid HCOOH, to which you call formic acid. Okay, so in the esters the formic acid becomes formate, ethanoic acid become ethanoid, propanoic acid become propanoid, butanoid, pentanoid, like that. Okay, esters having suffix. Okay, it having suffix, its suffix means those alphabets which are attached at the end of particular word. Okay, prefix means before that word, like di, tri, tetra, and suffix means after ending the word some letters are there, like OH, alcohol, alkane, ANE, alkene, ENE, alkyne, YNE, like this. Okay, suffix is ATE. Okay, ATE, like your word will be here and its ending with the ending of that letter will be with ATE, 8. Okay, so you know this is a formic acid, so you know you can call it as a formate. Okay, its name will be formate, FORMATE, formate. But you know here the hydrogen atom is replaced by any alkyl or aryl group. Okay, so here I removing this hydrogen and going to attach here an alkyl group. Okay, like example CH3. Okay, so it is a formate. Okay, from formic acid it will be made up of. Okay, so it is a formate, but methyl group is attached there So we call it as a methyl format. We call it as a methyl format. Okay, easy. Then one more example. Okay, see, these are the common names. So I always telling you two names, common name and IUPAC name. Okay, common name, and here IUPAC names. Okay, here IUPAC names. Okay, so methyl format, and to which you format to this formic acid, you can also say it is a methanoic acid. So methanoic acid, so we call it as a methanoate. Okay, methanoate, NOATE, methanoate. Okay, methanoate. Okay, next, so methyl group is attached there. Okay, hydrogen atom is replaced by methyl group, so to which we call it as a methyl methanoate. Methyl. Okay, methyl methanoate. Okay, are you getting my words, my handwritings? Okay, methyl. Okay, methyl methanoate, YL, methyl methanoate. Okay, like this. Next, taking another example, here is also one more example, HCOOH. Again, this is a formic acid, but instead of this hydrogen, okay, I am replacing this hydrogen. Okay, replacing this hydrogen and going to attach here ethyl group. Okay, ethyl group C2H5. So its name will be, instead of methyl there is a ethyl group. Okay, so its name will be ethyl format. Okay, we call it as a ethyl format. Ethyl format. Ethyl format. Okay, next, here we said one carbon containing acid. So one carbon containing acid is a again methanoic acid. So we call it as a methanoate. Methanoate. But ethyl group is attached. Hydrogen atom is replaced by ethyl group. So ethyl methanoate. Ethyl methanoate. Easy? Next, let's taking another examples. Okay, see, their name is ending with the ATE. Look this, ATE, Easter, ATE, Easter. Okay, ATE, ATE. So esters are ending with the ATE. Okay, the suffix ATE. Okay, next, taking another example, see, CH3 COOH. Okay, and just before in my previous lecture we sing about the names, common and IUPAC name of the carboxylic acid. You know this is an acetic acid in common name. Okay, you just see the notes. Okay, this is an acetic acid, so its ester will be acetate. Okay, its ester will be acetate. Okay, and the two carbon containing acid, so you call it as a ethanoic acid. Okay, two carbon ethanoic acid, so ethanoate. Okay, ethanoate, ETHANOATE, ethanoate. Okay, but here the hydrogen atom is going to replace it. Okay, here I am removing this hydrogen. Okay, hydrogen atom is replacing it with any methyl or ethyl group. Here I am taking methyl group. Okay, CH3, methyl group. So its name will be acetate. Definitely acetate it will be. Okay, but its name will be methyl acetate. Okay, methyl acetate. Why methyl acetate? Because the methyl group is attached here. That's why methyl acetate. Here I am just highlighting these words. Okay, so as like a methyl, so methyl. Okay, ethyl, so here is also ethyl. Okay, here methyl, so here is also methyl. Okay, and this particular word, see, listen, one carbon acid, so format. Okay, one carbon acid, so formate. Okay, two carbon acid, so it is a acetate, because we call it as a acetic acid, no? So that's why it will be acetate. Okay, so here one carbon containing acid, so methanoic acid, so methanoate. Okay, one carbon containing acid, okay, methanoate. Okay, next here methyl group is attached, excuse me, methyl group is attached, so it will be a methyl methanoate. Ethyl group is attached here, ethyl group, so it will be ethyl methanoate. Okay, so methyl group is attached, so its name will be methyl ethanoate. Methyl ethanoate. Okay, so why it will be methyl? Because the CH3 group, methyl group is here, so methyl, then two carbon containing acid, 1 2. Okay, two carbon containing acid. Okay, it was two carbon containing acid, that's why it is a ethanoate. Okay, three carbon containing acid, propanoate. Four carbon containing acid, okay, butanoate. Five carbon containing acid, pentanoate. Okay, if it will be ester, only and only you can convert this formic acid to formate whenever it will be an ester. Okay, let's take another example. CH3 COO, and here if here will be H. Okay, you again says acetic acid, so its ester will be acetate. You can easily call it as a acetate, ACETAT, acetate. Okay, because it will be acetic acids, that's why it is called it as a acetate. Okay, and here ethanoic in IUPAC in nomenclature, it is a two carbon, means ethane, so ethanoic acid. Okay, so we call it as a ethanoate. Ethanoate. Okay, ethanoate. Okay, so tell me here, here hydrogen atom is, I am going to replace it. Okay, so removing this hydrogen atom, and here I am going to attach some another alkyl group as like a ethyl, C2H5. So tell me its name. Okay, so here ethyl group is attached, so its name will be ethyl acetate. Okay, of course it will be acetate, but it will be ethyl acetate. Okay, here is also ethyl group I am writing, ethyl. Okay, ethyl ethanoate. Okay, so always remember that this ethyl, here it will be ethyl. Okay, here it will be ethyl. Okay, and here will be, it was a two carbon containing acid, so that's why acetate. Okay, in IUPAC name ethanoic acid, so ethanoate. Okay, easy now. Next, sometimes we are also taking a salt. Okay, okay, taking another example. mm, Propanoic acid, you can easily tell. Okay, CH3 CH2 COO, CH3. Okay, try its common name and IUPAC name. Okay, try by yourself, just try it. Okay, so 1 2 3, three carbon containing acid it was. Okay, it was three carbon containing acid, so it will be, tell me, three carbons means propane, so propanoate. Okay, here I am writing its name, propanoate. Excuse me. Okay, propanoate. 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 Because propionic acid, so that's why propanoate. Okay, and methyl group is here, na? So methyl propanoate. Methyl propanoate. Is it? Then here it's same. Okay, here propionate. Okay, so we can call it as a propionate or propanoate. Okay, methyl propionate or propanoate. Okay, let me make some correction here. Propionate. Propionate. PROPIO. propionate. Okay, because in common name it will be a propionic acid, so propionate, Pionate, propionate. Okay, propionate, Propionate, propionate. Okay, next in the IUPAC name it will be a methyl propanoate, methyl propanoate, propanoate. Okay, easy. Then taking some aromatic. Okay, easy now. Are you getting understand? Okay, taking another page here. I think it's all are easy. Okay, easy to understand now. Here is a methyl, so that's why methyl. Okay, methyl. Okay, and one, two, three, three carbon containing acid. Okay, three carbon. One, two, three, three carbon. So propane, propionate. Okay, propanoate. Okay, next, changing the page. Next. Okay, talking about some aromatic. Okay, just provide me only any one name. Okay, common IUPAC. Okay, COOCH3. Okay, excuse me. Okay, if there will be a H, you say it will be a benzoic acid. So its hydrogen atom is going to replace. Okay, so benzoic acid becomes a benzoate. Okay, benzoate, Benzoate, benzoate. Okay, so this hydrogen atom is replacing with any alkyl group. Okay, here I am attaching an alkyl group like methyl. Okay, CH3. So methyl benzoate, its name will be methyl benzoate. Okay, next here COOC2H5. So its name will be ethyl benzoate. Ethyl benzoate. Okay, and sometimes few salts are also there. Okay, few salts. Okay, let's talk about few salts. Okay, its name is also similar. These are also comes under the category of esters. Okay, but here I'm not going to attach the alkyl or aryl group. Okay, you just take an example. Okay, just listen to it. Here COOK. Okay, or Na. Okay, first Na, so Na plus and O carries minus charge. Okay, O carries minus charge. Okay, minus charge. So Na carries plus charge. Okay, and Na carries plus charge and O carries minus charge. So here will be the sodium. So sodium benzoate. Sodium benzoate. Potassium. Let's take another example. COOK. Excuse me. COOK. Okay, so K carries plus charge and O carries minus charge. K carries plus charge and O carries minus charge. So its name will be potassium benzoate. Potassium benzoate. Excuse me. Potassium benzoate. Potassium benzoate. Taking some aliphatic salts. Okay, aliphatic salts. Example CH3 or HCOONA. Okay, plus and minus. So its name will be, sodium formate or sodium methanoate. Okay, its name will be sodium formate. Common name. Okay, sodium formate, and its IUPAC name you call it as a sodium methanoate. Okay, similarly, if there will be a CH3COONA, okay, so Na carries plus and O carries minus charge. Okay, this example is quite too common. Okay, it's a common example. Okay, common example. Okay, IMP. Okay, important. So its name will be sodium acetate. Sodium acetate, because it comes from the acetic acid. Na? H is replaced by Na. Okay, sodium acetate, or you can also say sodium ethanoate, because two carbon in IUPAC it will be called as ethanoic acid, so it will be ethanoate. Sodium ethanoate, ETHANOATE. Sodium ethanoate. It's a dot, huh? Sodium ethanoate. Okay. Yes, I think there is this much examples are sufficient. Okay, taking one more for you. COOK, K carries plus and O carries minus. Its name will be potassium acetate. ACETATE, potassium acetate. Okay, or potassium. So two carbons means ethanoic acid. So ethanoate, potassium ethanoate. ETHANOATE, ethanoate. Okay, see, Na is replaced by only K. Okay, here Na, here K. So instead of sodium you write potassium. Instead of sodium you write potassium. Okay, ethanoate. Here above acetate. Exactly the same. Okay. Okay. Excuse me. Okay, I think easy. Okay, these are some esters. Okay, and some salts. Okay, like here the suffix. Excuse me. Its suffix is ate. Ate. So these are the ester like. Okay, ate. Ate. But why we call it as a salt? Why? Because here it carries a positive and negative charge. Highly electronegativity difference between the plus and minus. Okay, potassium, sodium are highly positive, and oxygen is highly electronegative. It does not forming any covalent bond. It will be a purely ionic bond. That's why we call it as a salts. Okay, but its name will be like esters. Okay, next. So I completed here the esters. Then let's talk about the amides. Okay, let's talk about amides. Give big heading, amides. Okay, so amide is not a well famous. Okay, yes, in biology it's amide linkage will be there. Okay, of course. So we have to learn about these amides. Okay, so as like here, what is amide group? Okay, these are the similar with the, these are the analogous with the amines. Okay, so bond NH2. Okay, these are the amines. Okay, primary amine, secondary amine, tertiary amines. Here is also amides. Okay, just before the NH2 here will be C double bond O group. Okay, and the amides are particularly neutral in nature. They are quite neutral in nature. You know very well that amines are basic in nature, but amides are neutral in nature. Amines, listen carefully. Amines are basic in nature. Amines was basic in nature, but here amides In this case, amides are neutral in nature. You know urea, okay, so it is a neutral in nature. Why? Because carbonyl group is there. Okay, this carbonyl group is highly electron deficient, so it does not allow this nitrogen to donate its lone pair. Okay, here nitrogen carries a lone pair. Okay, lone pair of electron, a lone pair, a single lone pair. Okay, two electrons. So this carbonyl group does not allow these lone pairs to donate someone else. Okay, that's why its basic nature is vanished. Okay, due to this carbonyl group. Okay, so that's why amines are basic, but these amides are neutral. Okay, amines means without carbonyl, and amides means with this carbonyl. Okay, see here. Here in this case also amides are primary, secondary, and tertiary. These are the primary amides. Okay. Here the hydrogen atom is replacing. Okay, like C double bond O NH, and here will be some alkyl or aryl group. Okay, so it will be a secondary. Okay, and if there will be a C double bond O and only nitrogen here with two bonds, single single. Okay, it will be a tertiary. Okay, tertiary. So primary, secondary, and tertiary. Okay, and H2 will be there. It will be a primary. Okay, primary amides. Okay, primary amides. Okay, so this is H is replaced by some alkyl groups or aryl groups. It will be secondary and it will be a tertiary. Easy. Primary, secondary, and tertiary amides. Okay. Let's talk about its name. Okay. Uh, you know HC double bond O NH2. We call it as a formamide. Okay, formamide. Okay, formamide. So one carbon, methanoid. So methanamide. We also call it as a methanamide. Okay, methanamide. 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 Okay. Next, if two carbon will be there, CH3 C double bond O NH2. Okay, so it will be acetamide. ACETAMIDE. Okay. Next, this is also called as ethanamide. 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 Okay. Next, propanamide. Here is same. Names are same. Propanamide, butanamide, pentanamide. Okay. Then here hydrogen atom is replaced. Certain examples like HC double bond O NH2. Okay, its name will be formamide. Okay, its name will be formamide. You know very well. FORMAMIDE, formamide or ethanamide. Okay, but here I am removing this hydrogen and replacing with another methyl group and all these things. Okay, methyl group. Okay, so if there will be a methyl group, okay, so it will be called as a methyl formamide. Methyl formamide. If there will be ethyl group, then ethyl formamide. Okay, propyl formamide, as like this. Okay, so the amides are quite easy, and nowadays these are not going to discuss much more. Why? Because listen, amides are not that much of useful. Every chemical is useful, but the demands of amides are quite less than other compounds. Okay, but here we are not. I'm not telling about to that their utility is less and more. Okay, of course each and every chemical is important. Okay, their importance is in different field. Okay, but still amides are suppressed. But amides are why amides are famous. Only there is a one reason, because it contains nitrogen and still these are the neutral in nature. Nitrogen containing neutral compounds are amides, and these are not explosives because nitrogen containing nitro groups are explosives. Okay, and nitro groups are also neutral compounds, but nitrogen containing this functional group is neutral and does not explosive anywhere else. Okay, and nitrogen containing many compounds are basic in nature, but this is a neutral in nature, and it tries to maintain the pH of soil. Okay, so that's why amides are quite important in our day-to-day life. Okay, amides. Okay, next, more examples you can take it here. Okay, I think after looking much more examples we can conclude the same. Okay, so okay, one more thing, propanamide, CH3 CH2 C double, excuse me, C double bond O, and here NH2, propanamide. It is also same, so E is replaced by amide. Okay, so the name propane, Propane. Okay, but this E is replaced by amide. Okay, this E is replaced by amide, AMIDE. So propanamide, butanamide, pentanamide is like this. Okay, quite easy. Okay, next, let's discuss about the its aromatic compound as well, like a benzenamide. Okay, here benzene, and here NH2. Okay, but C double bond O, NH2. Okay, so its name is acetanilide. Okay, benzamide, BENZAMID, benzamide. Okay, very much important. Okay, acetophenone. Okay, it is also called as acetophenone. It's okay. No acetone of, no acetone of. Okay. Next topic is secondary amides. I already told it. Okay, told you. Then tertiary amide is also there. Okay, let's discuss much more. Okay. Okay, let's talk about the secondary amides. Here is an example of secondary amides as like a methyl formamide. Okay, let's discuss much more according to your syllabus. Okay, so as like a C double bond O and H. Okay, and here will be an alkyl group. Okay, so is as like its example, its name will be these are, we are going to talk about the secondary amides. Secondary amides. Okay, few examples here I am taking, like H. Okay, or CH3, and here will be the methyl group. Okay, methyl group. Okay, so 2 carbon, it is a acetamide. Okay, 2 carbon acetamide. Okay, that much, up to this is a acetamide, ACETAMIDE, acetamide. Okay, but the methyl group is attached to this nitrogen, the extra. This is the extra methyl group is attached to this nitrogen. Okay, so it is a N-methyl, because on this nitrogen the methyl group is attached, so that's why we call it as a N-methyl acetamide. Excuse me. Okay, so it's a N-methyl. Okay, N-methyl. Okay, capital N. Capital N means nitrogen. It is not a small n. N-methyl. Okay, why? Because to this nitrogen the methyl group is attached. Okay, to this nitrogen the methyl group is attached, so N-methyl acetamide. Okay, acetamide, up to this. Okay, So that's why it is a acetamide. Okay. Next, you can take more examples here. Um, CH3, CH2, C double bond O, NHC2H5. Okay, go ahead, try by yourself. Okay, try it. Okay, so to this nitrogen, the ethyl group is attached now. To this nitrogen, the ethyl group is attached. Okay, so what you will call it as a N-methyl, na? And to this N, to this nitrogen, ethyl, sorry, N-ethyl. So N-ethyl, N means nitrogen, to this nitrogen, ethyl group is attached. N-ethyl, okay, then 1, 2, 3, 3 carbon, okay, so means which amide? 3 carbons means propane, propanamide. Propanamide, propanamide. Okay, you can see the N-ethyl, so N-ethyl. Okay, and the remaining structure, this remaining structure is nothing but the 1, 2, 3, 3 carbon. Okay, so that's why it is a propanamide. Okay, you remember this blue colored structure. Okay, blue colored structure. So blue color structure, that is nothing but the propanamide, or to this nitrogen the ethyl group is attached, so N-ethyl propanamide. Okay, next, okay, that much is sufficient. Okay, taking the tertiary amines, tertiary amides, tertiary amides. Okay, tertiary amides, here I am taking the example like CH3, C double bond O, and okay, up to this, if there will be a NH2, then you say acetamide, na? Okay, its name will be acetamide, acetamide, acetamide. In IUPAC you say ethanamide. Okay, and here I am going to attach to this nitrogen methyl, CH3, CH3. Okay, so listen, up to this blue structure, it will be called it as a acetamide, 2-carbonamide acetamide. But listen, here 2 methyl group is attached, and this methyl group is attached to this nitrogen. Okay, so that's why we call it as a N. First N for first methyl, second N for second methyl. Okay, N. How many methyl? Dimethyl. 2 methyl. So dimethyl. Okay, N dimethyl acetamide. Okay, so you can see this N dimethyl. Okay, then acetamide. So for these two, N dimethyl. Okay, if there will be a 1 methyl and 1 ethyl, then so as like CH3, C double bond O, N, and 1 methyl and 1 ethyl. 1 methyl and 1 ethyl. Okay, now what we call, okay, see here, this is also 2 carbon. Okay, 2 carbon containing amide, so to which we call it as a same here acetamide. Okay, blue colored structure, acetamide. Okay, so here I am writing acetamide, ACETAMIDE, acetamide. Okay, and after that, see here on this nitrogen, methyl group is there and ethyl group is also there. Okay, to this nitrogen. Okay, so N for methyl, N for ethyl. So N methyl, N ethyl, or N ethyl then N methyl. So ethyl come first or methyl come first, you know very well. Okay, so first methyl. Okay, first methyl and second then ethyl. Okay, remember this. Okay, because ethyl come first. Okay, that's why. Okay, its name will be N for ethyl. Okay, first ethyl, N ethyl, and then N for methyl. Okay, N methyl, then N ethyl, N methyl, N ethyl. Yeah, N methyl. I forget. Excuse me. Okay, methyl, N methyl. Hmm. First ethyl comes now. Excuse me. Excuse me. I'm so sorry. Ethyl, then methyl. Okay, excuse me. Okay, excuse me. I create some confusion here. Okay, I'm sorry. N ethyl, first ethyl, then N methyl. Okay, methyl. N methyl acetamide. Okay, N methyl, N ethyl acetamide. Okay, please don't confuse. Okay, N ethyl, ethyl come first. Okay, then N methyl, then M comes. Okay, so N ethyl, N methyl acetamide. Okay, easy. So these are the some primary, secondary, and tertiary. Okay, so these are the amides, particularly the primary amides. Unfortunately, here I am taking an example of a secondary amide. Okay, so you can say it's a secondary amide. Okay, then secondary amide is here, and some tertiary amides are here. Okay, then uh, little bit. Okay, some says that much is sufficient. Mm, then our upcoming topic is acid anhydride. Okay, just a little bit I'm giving a hint here. Okay, acid anhydride. Okay, acid, excuse me, acid anhydride. Our upcoming topic is acid anhydride that we are going to discuss tomorrow. Okay, here I stop. Thank you. Bye bye.